Hi guys, here we are with the start of 9.5 hyperbolas. Hyperbola is a set of all points in a plane such that the absolute value of the differences of the distances from the foci is constant. Okay? You can see these pictures here in your notes where everything's labeled for you. You can read through those vocab. Okay? Very simple, or very similar to our ellipse formula, except now it's a minus in the middle equal to 1. And because it's a minus in the middle, it means that the order is going to matter. Last time when it was plus in the middle, okay, it didn't matter if we had the x squared plus y squared or y squared plus x squared. It meant the same thing. Okay? But now with a minus in the middle, the order is going to really matter, so we have to pay attention to that this time. Okay? And whichever one's first is going to tell you which way your hyperbolas are going to open. If the x is in front, we're going to go sideways like this one. And if the y is in front, we're going to go up and down with the y-axis there. Okay, our focus points, this time our equation to get c is going to be c squared equals a squared plus b squared. With the ellipse, it was big squared minus little squared because our c was not the longest piece. So when we would rearrange those pieces into a triangle, the c was not necessarily the hypotenuse. This time, our c will be the longest piece, and it will be the hypotenuse, so it should look like our Pythagorean theorem. All right, and you will see that we'll get our vertices, and then our focus points. Okay, and our co-vertices are going to be up here. They're not really doing a whole lot for us. They will be part of this rectangle that we'll graph out to help draw our asymptotes that kind of guide our hyperbola. And those asymptotes have the equation of plus or minus b over a times x. Alright, still need to account for any translation. Okay, our first part here today, we're not going to have any translations with that. Okay, so let's take a look. Alright. Our first one here, we're going sideways, so that means we're going to have an x squared first. Okay, we should have x squared first. Alright, we can see that we're going to be centered at 0, 0. That's going to be halfway in the middle of my vertices as well as the focus points, my foci. So I know I've got something that looks like this. Okay, what's my distance, my horizontal distance from my center? From here to a vertex is going to be 5. Okay, it's going to be 5, and 5 squared is 25. Okay, so my A was 5. I don't know B yet. C is radical 41. Okay, so let's find that out. What is B? So we have the square root of 41 squared equals 5 squared plus B squared. So B squared is 16. So that makes 4 equal to B. So we're going to put 16 there. Okay, so that's all we needed to answer this question, right? An equation for the hyperbola. That's all we needed there. Let's go the extra mile here. Okay, let's go the extra mile. And so if our B value was 4, that's my vertical. So my co-vertices would be there and there. Not really doing a whole lot for me. And my asymptotes, y equals plus minus b over a times x would be 4/5 x. Okay? So we'd go up 4 over 5. That's plus minus. So I'm going to go down 4 over 5. Oh, 5, not 6. 5, 5. Okay, we're going to go the same thing other side. And you can see this rectangle we could connect from those slope points for our asymptotes. Our vertices and co-vertices would also be on it. Okay? And we're going to do a dotted line connecting the corners of our rectangle. Okay, and you'll see how those two lines will kind of guide your hyperbola. Okay, same thing with part B here. It's opening up and down, so I know y squared is going to go first. It's centered at 0, 0. Okay? Y squared's first. Alright, what's my vertical distance? 2, 4, 6. Okay? So it's going to be over 36. Alright, so my B is 6. C is 8. Nope, not quite. Okay? They get kind of tricky on some of these. It looks like that's at 8, but we have a little arrow over here. This is actually the square root of 61, very close to 8. So we need to find what A is. So again, the square root of 61 squared equals A squared plus 6 squared. Okay, and we'll get 5. So 25 goes under there, 5 squared. And there's our equation. We got the equation. That's what it wanted. Alright, let's go the extra mile. We can plot things out here. So A is 5. So 5 would come out to here. And negative 5. Okay, our slope plus minus B over A. 6/5 times X. Okay, so I go up 6, out 5. Down 6, out 5. 6 and 5. 6 and 5. Okay, and if you want, you can draw that little rectangle. Not required, but it's just a nice visual aid. Okay, this is required. The asymptotes that connect the corners of that rectangle and there you go. This one requires a shift. We might come back to that one later at the end if there's time. Okay. We're going to skip all the way to number 3. Alright. Skipping all the way to number 3. Vertices at negative 7, 0 and positive 7, 0. Okay, write an equation for this hyperbola, and it has a conjugate axis length of 10. Okay? So what does this tell me here? This tells me that we're going to be opening this way. We're centered at 0, 0. So I'm just going to have x squared. Well, it's x squared first because it's going to be going sideways. Excuse me. Okay, and we're going to be centered at 0, 0, so I'm not going to have anything extra in there. And I know what my A is already. 7. So 7 squared is going to be 49. Okay, now what? What's this conjugate axis length of 10? Okay, let's flip back. Alright. The conjugate and transverse axis. Okay, the two axes of symmetry of every hyperbola. The conjugate axes will connect our co-vertices. So if that has a length of 10 all the way across, from my center then should only be 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That tells me that my B value equals 5. And 5 squared is going to be 25 down there. Okay? So there is the actual equation part. Let's see if we can get this all the way through and graph it. Okay? Well, I can do my y equals plus minus b over a, so 5 over 7 times x. So from my center, I'd go up 5 over 7, down 5 over 7, 5, 7, 5, 7. So if you get the vertices and co-vertices, it's pretty nice because they're going to give you like a little reference point of where your slope line should go. Okay, so we're going to go 5, 7 this way. Dotted lines for our asymptotes because they're not actually included as part of the graph. Okay, and focus points. C squared equals A squared plus B squared. 74, okay, square root of 74, roughly 8.6. So 7, 8.6, 8.6, so somewhere out in there. Okay, and this is going to follow, I should have extended these even further. It's going to follow those out like that. There we go. Not too tough. Not too tough. We're going to skip 4. We're going to do 5 together. Vertices at 0, 2, and 0, negative 2. Okay, that tells me that it's opening up and down, so y squared's first. It also tells me that my center's at 0, 0, so I won't have any adjustments. Alright, foci at plus minus radical 5. Square root of 4 is 2, square root of 5 is just barely beyond 2, so we can drop those down now. Alright, this is going to give me my b value. B is 2, so 2 squared is going to be 4. Okay, let's see if we can figure out what we need for our a. Okay, so c squared, square root of 5, squared equals a squared plus b was 2 squared. 5 equals a squared plus 4. So 1 is going to equal a. And we'll still put it under there, even though x squared over 1 is just x squared, we'll leave it there. Okay, so if you want to, you can put those out there. They're not really part of it, but they do kind of help with our lines. Okay, y equals plus minus b over a, 2 over 1 times x. So from my center now, we go up 2 out 1, down 2 out 1. Okay, the nice thing about putting those covertices out there is it does kind of help with making the rectangle here. We're going to connect our diagonals, dotted lines. Okay, we're going to be at our vertices, bending around the focus points here, the foci, and following our asymptotes out. Beautiful. Beautiful, beautiful, beautiful. Okay. Doing good? Alright, let's do another one. Equation for hyperbola with vertices at negative 5, 0, 5, 0. Alright, so this tells me a lot of stuff. What does this tell me? Where's my center going to be? 0, 0. Okay. Which way is it going to be opening? Sideways. X goes first. There's 0, 0, so I'm not going to have any shifts, so I can just put this down right away. Minus. Okay. What's my A value? My horizontal distance from center to vertice. 5. 5 squared is 25. Okay. It gives me my C value over here. Okay, the square root of 25 is 5, so the square root of 26 is just going to be barely beyond it. Okay, and now we can figure out what B is. Okay, my C value there is the square root of 26 squared equals 5 squared plus B squared. Subtract that over, and just like before, we're going to get 1 for our B value. Well, it was our A value last time. We'll get 1 this time. Okay, so if you want to, you can put them up there. 1 up from the center, 1 down from the center for your covertices. Plus minus B over A, 1/5 x. So I'd go up 1, out 5. Down 1, out 5. in each direction. So we had up 1, out 5, down 1, out 5, up 1, out 5, down 1, out 5. Okay, it makes a nice little rectangle there. Okay, we connected our corners, and now just like before, we started the vertex bend around the X, or not the X, the focus point there. That's what the X represents. And follow your asymptotes out. Okay, let's have you try 4 on your own there. Go ahead and push pause. Okay, that's very similar to the one, number 3, with the conjugate axis. Think about how that helped us out last time. Okay, so go ahead and hit pause and try that one on your own. Alright, welcome back. We got -4, 0, 1, 2, 3, 4, +4, 0. Okay, this tells me we're going side to side. The x squared is going to go first. Well, it also tells me we're centered at 0, 0, so I don't need to worry about any translations, any shifts. So that's why we're just jumping right to x squared. Okay, it also tells me my a value is 4, so 4 squared is 16. Conjugate axis length of 6, so it's going to be 3 up and 3 down from the center. 1, 2, 3, 1, 2, 3. For my co-vertices, that tells me that my b value is 3, okay, which should make this 9. Y equals plus minus 3/4 x for my asymptotes, and my c value, c squared equals 16 plus 9. C squared is 25, so my focus points will be at 5. And -5. Okay, so asymptotes, up 3/4, down 3/4, up 3/4, down 3/4. You can see the rectangle there formed by our asymptote slopes and our vertices and co-vertices. Connect the corners. Alright, and we'll start here and follow those out right around. Alright, we got a couple minutes left here. Let's take a look back at that very first one. Just a little sneak peek here with just a little sneak peek here on the shifts a little bit. Okay? Don't think you're going to have any homework like this today, but let's just take a peek at it and see how it goes. Okay? My vertices are at -1, -2, and 3, -2. Okay, so that halfway through there is going to be 1, -2. My center is going to be at 1, -2. Okay, so let's pretend that that is my new 0, 0. Alright. So just like before, okay, we would have to do our shifting here. Okay, let's figure out what else we got. Our a value is 2. Our a value is 2. Okay, they don't give me my c. The b value here is going to be pretty tough to get. What do they give us that we could use to find our b value? Okay, think of our slope equation here for our asymptotes. y equals plus minus b over a times x. What's the slope appear to be here? I'm going up 2 over 1. So my b over a needs to equal 2 over 1. I know that a is 2. Okay? So what would that make b have to be? You can cross multiply here, and b equals 4. Alright? So for our equation, it's opening sideways. Okay? We have x, and we're 1 to the right, so minus 1 squared minus y, 2 down, so plus 2 squared equals 1. Ran out of room. Bad choice. X minus 1 squared minus y plus 2 squared equals 1. Okay, my a value is 2, so it's going to be over 4. My b value is 4, so 4 squared is 16. Okay, there it is. This little extra for you. Just like circles, right? It's opposite of the center, so x minus 1. If it was 1, it's going to be x minus 1. Negative 2, we're going to have y plus 2. Opposites. Alright, then we're just over our a squared, b squared. Okay, I don't think you're going to have to do too many of those. Alright, homework for tonight. Homework for tonight. Let's go with page 628. Alright. 10, 11. If you want to do one of those last problems that we just did, where you have to use the slope of the axes, you can try 12 and 13. And then we'll do 37 through 42. And those are going to be similar to these. Oh, sorry, I'm off the page. Page 628, 10, and 11. Those are like the first examples we did where it's nice and centered at 0. Well, they're not centered at 0, 0. But you can get A and B and C from the picture pretty easily. 12 and 13, if you want to try those, you can. Those are similar to that very last example we just did. And 37 to 42 are like the word ones that we did right here. Okay? All right. Thanks for watching. Good luck.